Okay, so this is our worksheet for chapter 1. A good idea will actually be to download the worksheet from the Canvas page and try to complete the worksheet on your own before you watch this video. Okay? Once you watch this video, if you have any question, do not forget that you can always seek help by contacting me or visiting the tutoring center, the online tutoring center. The first problem is about matter. And the first problem asks us to describe each of these as an element, a compound, a homogeneous mixture, or a heterogeneous mixture. A, an alloy of gold and tin. So first of all, do you know what an alloy is? An alloy is, per definition, it's a solid, homogeneous mixture. So every time you see the word alloy, you should know that we're talking about a solid homogeneous mixture. And this solid homogeneous mixture is composed of two substances that are mixed. So two mixed substances, and these substances are gold and tin. B, phosphorus trichloride, a substance containing phosphorus and chlorine atoms in a 1:3 ratio. So what kind of information do we have here? We see that we have and. And means that we have two kinds of atoms. We have the phosphorus and the chlorine atom. So here we have two kinds of atoms. Two different kinds of atom. These atoms are present in the substance in a fixed ratio. So we have here a fixed composition. Based on all these elements, okay, we are in presence of a substance made of two kinds of atoms in fixed composition. Therefore, phosphorus trichloride is actually a compound and it's a pure substance. C, titanium metal, a substance containing only titanium atom. So what do we see here? We have the term only titanium atom, only. So if it's only, it means there's only one kind of atom. We are therefore in presence of a pure substance element. D, Earth atmosphere, which contains about 78% nitrogen, 21% oxygen, and small amounts of other gases. So what do we have here? We're talking about gases, okay? And you have different kind of gases. You have nitrogen, oxygen, and small amounts of other gases. Therefore, you have different substances mixed together, okay? This means here that I have different substances, different gases, and these gases are mixed together. So because these gases are mixed together, we are in presence of a mixture. The question is it an homogeneous or an heterogeneous mixture? Well, remember that everything has to do with what, if you see one layer throughout, it's going to be homogeneous. If you see two or more layers, okay, naked eye, then it means you have an heterogeneous mixture. So look around you. That's the atmosphere around you, okay, the air, the earth atmosphere. What do you see? It's only like, it looks homogeneous, right? Naked eye, you only see one layer throughout. So because we're looking at the atmosphere, it's going to be homogeneous. Therefore, we are in presence of an homogeneous mixture of gases. E. Blue cheese dressing, a creamy white sauce containing small chunks of cheese. So, what is this blue cheese dressing classified as? We have chunk of cheese and it's a white sauce. So we know, due to the fact that we have here a creamy white sauce, we know that a sauce is composed of different substances mixed together, okay? Therefore, it's going to be a mixture. And this mixture presents small chunks, so visible particle, visible chunk of cheese. This makes the mixture heterogeneous. In the second problem, you need to identify each of the following as solid, liquid, or gas. Those are the three states of matter. A substance made up of particles that are close together but able to move freely past each other. So we have two information here, close together, move freely. These two information are representing the liquid states. B, a substance made up of particles that are far apart and have almost no interaction with each other. Sorry. So far apart, no interaction. This is the definition of the gas state. C, a substance with a definite volume but no definite shape. Definite volume, no definite shape. This is the definition of, again, the liquid state. Problem 3. Describe each change as physical or chemical. A. The paint on a new truck has a shiny red color. Here, there's no idea of anything that is new, okay? Therefore, it's just a fact. The paint of the truck is actually shiny red color. So we're stating the fact. The color, smell, taste, all of these are classified as physical changes, okay? Physical property. So here, the fact that the truck has a shiny red color, it's physical. The metal wire conducts electricity. The fact that the metal can conduct the electricity is as well a physical property of change. Magnesium metal reacts with hydrogen chloride gas to form magnesium chloride and hydrogen gas. So here you have two keywords. The fact that there's a reaction and a reaction to form something new. So what is new? The magnesium chloride and the hydrogen gas. So we have new products. Therefore, this change is chemical. Water is heated and it becomes steam. So first of all, we have to know what steam is. Steam is actually water in the gaseous state, okay, is water vapor. Therefore, the water went from being liquid to being in the gas state. Before and after, it's still water, okay? There's no new product that has been formed. We just have a change in state of matter from liquid to gas. Therefore, it's physical. 4. Aspirin is a substance that is commonly used as a pain reliever. Describe each of the following properties of aspirin as chemical or physical. Aspirin is a solid at room temperature but melts at 136 degrees Celsius. Here, characteristic of physical property. It's solid when it's at room temperature. The melting point is 136 degrees Celsius. This is physical. Aspirin reacts with the compound sodium hydroxide to form 2 new compounds. Okay, so important, reacts and 2 new compounds are formed. Therefore, it's chemical. When a person takes an aspirin, a substance in the stomach reacts with the aspirin, breaking it into 2 simpler compounds. Again, what do we see here? We have reacts and into 2 simpler compounds. So there's an idea of something new being formed. Therefore, again, it's chemical. Let's take a look at the back of the page now, where we're going to talk about energy and change. So here, the image that you see there represent the atoms of a substance before and after a change occur. So we have here before and here after. You need to use this image to complete the table below. So what do we want here? Is this an element, compound, or mixture before and after the change? So let's take a look at before. What do we see? In the container before, we observe that we have the same organization of atoms together, okay? So we have here every single substance that I circled consists of 2 atoms of hydrogen for 1 atom of oxygen. So it's a fixed ratio. This is a compound. And as you can see, I only have 1 kind of compound. So this is a pure substance compound. Now, what do we have after? Well, after, observe that I have 1 substance that are circled in green. This substance consists of 2 atoms of hydrogen combined together, so 2 of the same kind. So here we have the element hydrogen, that is the first substance. And then we have another substance here that I circle in orange. And this is another element, the element oxygen. Why is it an element? It's because it's 2 atoms of oxygen combined and it's only oxygen, okay? So because it's only hydrogen in the green circle and it's only oxygen in the orange circle, I'm in presence of elements. But in this container, the elements are present together, okay? So they're mixed together. Therefore, what I have here represents a mixture of elements. So it's a mixture of the element hydrogen and the element oxygen. And as you can see, this mixture, it's not organized. It looks like pretty homogeneous, right? The distribution is homogeneous, so it's probably an homogeneous mixture. Now you're asked to determine how many atoms are present. So what are atoms? Atoms are actually represented here by a sphere. So the number of sphere will give you the number of atoms. So you can count them on the before and count them in the container after. And if you count them, you will realize that you have 24 sphere before and 24 sphere after. This is due to a law that is called the law of mass conservation. You cannot create or destroy matter, so the number of atoms you have before is the same as the number of atoms that you have after. Then you're asked to figure out how many molecules are present. So molecule, okay, represents a group of atoms. So how many groups of atoms do we have before? So let's take a look at how many blue circle do I have? And if we count, we have 8 blue circle. On the other hand, on the right side, so how many green and orange circle do I have? And if I combine, I have 1, 2, 3, 4, 5, 6, 7, 8 green circle. And I have 1, 2, 3, 4 orange circle. Therefore, I have a total of 12 molecule on the right side. Because the molecule is how the atoms are combined together, there is no rule that says that you need the same number of molecule before and after. What you have here is the same number of atoms before and after. The difference between the before and the after is how the atoms are organized. Therefore, in this change, is it chemical or physical? Because we have the creation of a new compound, new products that are the oxygen element and the hydrogen element, we have a chemical change, okay, since new products are formed. In this change, electric energy is used to break water into its elemental form, hydrogen and oxygen, as we've seen in the picture. Based on this, which is more stable, the water or the combination of hydrogen and oxygen? So let's try to understand and write this down as an equation, okay? So we need electric energy. So we need energy to do what? When energy is applied to water, we obtain hydrogen and oxygen. Okay, so when this electric energy is applied to the water, we can break the water down into the elemental form, hydrogen and oxygen. Therefore, what you need to remember is the law of energy conservation. So the amount of energy I have before is the same as the amount of energy that I have after, okay? And whatever has the least amount of energy is the more stable. Therefore, I have the same amount of energy here and here. The water has less energy than the hydrogen and the oxygen combined, because in order to get the same amount of energy, I need to add more to the water. Therefore, water is more stable. Then you're asked to determine if this change is endothermic or exothermic. Well, remember this term, endothermic means that the energy comes in, exothermic, the energy goes out. Where in this case, we have to apply the energy to the water. So we need to add more energy. So the energy comes in, it's an input of energy before, therefore this change is endothermic. Finally, let's talk about the scientific method. Classify each of the following as an observation, a hypothesis, a theory, or a scientific law. So what usually students struggle the most is between theory and law. Just remember that theory answered the question how, the law answered the question what. What will happen? It's the law. You can predict the future. Why it happened and how it happened, this is the theory. So A, Through the process of natural selection, humans, bonobos, chimpanzees, and gorillas evolved from a common ancestor species. This is just how the process of natural selection is explained. Therefore, we have here a theory. By the way, a theory can always evolve with its time, okay? After teaching middle school science for several years, you notice that your student seems to be most engaged between 9 a.m. and 11 a.m. So it's a fact that you have observed, okay? You have noticed a pattern. You don't have an explanation for this pattern yet. There's nothing that's going to tell you that this will happen every year, okay? But this is, this will happen forever. But it's a fact, okay? So we call this an observation. You observed, you noticed what happened. Energy can be converted into matter in the ratio of E equal mc squared. This helps you to predict how much energy will be represented by an amount of matter at a speed, the speed of light squared. Okay, so you can actually predict how much energy can the matter have and vice versa. So because it's a prediction, this is actually a law. D, while gardening, you notice that plants on the north end of your garden are growing much better than those on the south end. You suspect that those on the south end may not be getting enough sunlight. Well, you observed something, okay? Your observation comes from the fact that you have noticed that the plants on the north end of your garden are growing way better, okay, than the one on the south end. And now you're trying to explain. You're not sure that this is the true explanation. You're going to have to try and to do some experiment to verify that what you're saying is true, but you're suspecting, you're emitting a suggestion of why this is happening. You suspect that those on the south end may not be getting enough sunlight. Therefore, what you're doing here is called, it's an hypothesis that will need to be tested. So this is closed chapter 1 worksheet. Hopefully a lot of the concept, this helped you to clarify some concept. Remember that you can always contact me if you need help. You can as well attend SI sessions or visit the online tutoring center, the Multidisciplinary Success Center. Bye-bye.